Hi guys, Assalamualaikum. My name is Muhammad Fakar Alim. I'm from UiTM Cawangan Terengganu, Campus Dungun. My matrix number is 2019 275052. And I and my friend gonna present is application of magnetically coupled circuit in transformer. The content that we gonna present is definition of magnetic couple, type of transformer, and lastly application of transformer. Okay, magnetic couple circuit made by James Clerk Maxwell, born in 1831 and died in 1876. Is graduate in mathematics course in Cambridge University. Remarkable paper is Laws of Faraday and Ampere. The rules that he produced is the right hand rule, and magnetic flux name is named after him. Okay, different between conductively coupled and magnetically coupled is conductive coupled is one loop effect, the neighboring loop through current conduction. Magnetically coupled is two loop with or without contact between them. It affect each other through the magnetic field generated by one of them. The transformer is the basis of the concept of magnetic coupling. Coupling is to transfer energy from one circuit to another. Transformer is key circuit element because the transformer is can stepping up and stepping down AC voltage and currents in power system. Electronic circuits such as radio, televisions, washing machines receive purpose as dependent matching isolation one part of a circuit from another, and again for stepping up and stepping down AC voltage and currents. So I'm gonna pass to my partner, which is Amira.
Let's continue with the types of a transformer. The first one is linear transformer. The definition of linear transformer is a linear transformer may also be regarded as one whose flux is proportional to the currents in its windings. A transformer is generally a four-terminal device comprising two or more magnetically coupled coils. The transformer is said to be linear if the coils are wound on a magnetically linear material, a material for which the magnetic permeability is constant. The second one is ideal transformer. Definition of ideal transformer is an imaginary transformer which has no copper losses, no iron loss in core, and no leakage flux. Characteristic of ideal transformer is the first one is zero winding resistance. Second one is infinite permeability of the core. Third one is no leakage flux. And the last one is 100% efficiency. The next slide. Okay, the difference between linear and ideal transformer is the first one is an ideal transformer has only a ratio of primary and secondary voltage. It, it has no leakage or magnetizing inductance or resistance. A linear transformer has primary and secondary inductance and resistance, and magnetizing inductance can have magnetizing resistance too. If the model is linear, it will not include saturation or frequency dependent loose terms from eddy currents and hysteresis, for example. These nonlinear effects are complicated to model and slow simulation down considerably. Okay, next presenter is Alia.
Okay, so I'm going to continue. Below the idle transformer, there's actually other two, which is the idle auto transformer and the three-phase transformer. So an auto transformer is a transformer with only one winding wound on a laminated core. An auto transformer is similar to two winding transformer but differ in the way the primary and secondary winding are interrelated. A part of winding is common to both primary and secondary sides. On load condition, as the figure below, a part of the load current is obtained directly from the supply and the remaining part is obtained by the transformer action. An auto transformer is made of three phases. So the second one is the three-phase transformer. The three-phase transformer is made of three sets of primary and secondary winding. Each set wound around one leg of an iron core assembly. Essentially, it looks like three single-phase transformer sharing a joint core as a figure below. Okay, next please. So the advantages and disadvantages of an ideal auto transformer. The advantages is it is much cheaper. It is the usage of copper is lesser and for the design and the construction, and the size is relatively smaller for easily the component to be put in the in gadgets or electrical appliances. So for the disadvantages, it does not have the primary to secondary winding isolation of a conventional double wound transformer. Then, an auto transformer cannot safely be used for stepping down higher voltage if the secondary side winding becomes open circuit, load current stops flowing through the primary winding, stopping the transformer action, resulting in the full primary voltage being applied to the secondary terminals. Next. So this is the advantages and disadvantages for the three-phase transformer. The advantages is it is require less time to assembling the components and it deliver more power. It has very high efficiency. The disadvantages is cost or it can be very costly and little bit expensive of standby units, and the repairing it can cost it can be a little bit more expensive for the repairing inconveniences. In case of fault or failure of the three-phase transformer, the power supply shutdowns in the whole connected load areas. Okay, next person.
So next, there are three applications of transformer. The first one is transformer as isolation device. Isolation transformer provide galvanic isolation between the AC power line and the power device. That means that there is not a DC path between the two windings. They serve three main purposes. The first one is isolating the secondary from ground. Second is to provide step up or step down of line main voltage. And lastly was to reduce line noise being transmitted from the primary to the secondary or vice versa. Next, transformer as matching device, or we can call as impedance matching. Impedance matching makes sure that the output impedance of one stage, called the source, is equal to the input impedance of the following stage, called the load. This mesh allows for maximum power transfer and minimal loss. This maximum power transfer occurs when the output impedance of the source is equal to the input impedance of the load, because if the output impedance is bigger than the load, the more power is lost in the source. Lastly, we have transformer as power distribution. A distribution transformer or service transformer is a transformer that provides the final voltage transformation in the electric power distribution system, stepping down the voltage used in the distribution line to the level used by the consumer. As they usually don't operate at full load, they are designed to have maximum efficiency at lower loads. To have a better efficiency, regulation in these transformers should be kept to a minimum. Hence, they are designed to have small leakage reactance. If mounted on a utility pole, they also called as pole mount transformer. Okay, that's it from me. Like, share, and subscribe.
So that's all for us. So thank you very much. Support us. So
Comment, comment. Don't forget to comment.
comment if you want more videos just like this. So thanks guys. See you later.